So I'm going to continue with chapter 10, namely section 10.2. We're going to continue with solving quadratic equations. We already did factoring, square rooting, and completing the square. Section 10.2 is about the quadratic formula. So we're gonna develop a formula that solves any quadratic equation, and the way to get the formula is by completing the square. So say you want to solve the quadratic equation. To solve the quadratic equation, and if we're looking at the general one, ax squared plus bx plus c equals 0. Since we don't know the letters, like they're not numbers, we can't do factoring and we cannot do square rooting because of the bx. So the only method that will work in this case is completing the square. Okay, the third method, completing the square. And to use completing the square, remember the steps. First, we move the constant over. So we get ax squared plus bx equals negative c, and then divide everything by a because we need to have a 1. Divide by a, as long as a is not 0, we can do that. X squared plus b over ax equals negative c over a. So now to complete the square, we take this value, which is b over a, and divide it by 2, which is timesing it by 1/2. B times 1 is b, a times 2 is 2a, and then square it. Remember completing the square, so you're going to square it, b squared over 4a squared. So we take that and add it to the left side of the equation and to the right side of the equation. And as we know now, this guy is going to factor into a perfect square. Remember the trick, we pull the x down, the sign is plus, and then we look over here, b over 2a squared. Now for these two guys to add, we need to have the same common denominator. We don't, so I times this by 4a to make it 4a squared on bottom. So we get negative 4ac over 4a squared plus b squared over 4a squared, which we can write as b squared minus 4ac all over 4a squared. So now we can do square rooting, and it's plus and minus. So we got x plus b over 2a equals plus or minus square root of b squared minus 4ac over square root of 4a squared, which is 2a. This guy is called discriminant. So subtract b over 2a to isolate x. X equals negative b over 2a plus or minus square root of the discriminant b squared minus 4ac over 2a, which we can write as one fraction because we have the same denominator, and this is what we call the quadratic formula. Quadratic formula. And this will solve any quadratic equation, no restriction, okay? Just write the equation in general form and then find a, b, and c and plug in, and it will solve any quadratic equation for you. If you recall the last problem I did in 10.1, I'm going to redo using the quadratic formula. I did it by completing the square. So here's the problem I'm talking about. Check your notes. So it's in general form, a, b, c. We write the formula. This has to be memorized. B squared minus 4ac all over 2a. B is 2, so that's negative 2 plus or minus square root of 2 squared. The 4 will always be there. A is 4 and c is 5 over 2 times 4. So instead of rewriting the whole thing over and over again, I'm going to work on the discriminant on the side. The discriminant, always do the exponent, then multiplication, then subtraction. Exponent gives me a 4. 4 times 4 times 5 is 80. And then minus, so 4 minus 80 is negative 76. I'm doing square root of negative 76. That's I square root of 76, which is I root 4 times root 19. 4 times 19 is 76, so that's 2I root 19. So this guy is going to go in there. So we get negative 2 plus or minus 2I root 19 all over 8. And you can see because we have a negative 76 under the square root, we end up with imaginary solutions. And we got to split it up to write it in standard form. So negative 2/8 plus or minus 2I root 19 over 8. We can reduce the fraction, and that's exactly what we got by completing the square. Okay. So now let's practice more of the quadratic formula. So use the quadratic formula to solve. Number 1, 40 plus 3 equals 40 squared. So we're going to write it in general form first by subtracting the 40 and the 3. So we get 40 squared minus 40 minus 3 equals 0, A, B, C. Now we're not going to write x equal because we're not solving for x, we're solving for t. So it's t equals the opposite of b plus or minus square root of the discriminant all over 2a. So if b is negative 4, the opposite of that is 4 plus or minus square root of this guy is always going to be positive because it's a square, minus 4 times 4 times negative 3 over 2 times 4. Again, let's work this out. That's 16. 48 plus 48 is 64. And if you look at 64 is a perfect square, so we can square root it and get a number, and that's how we know it could have been factored. So we could actually have factored the original one right there, okay? Because this is a perfect square. And we get two rational solutions. So t equals 4 plus 8 over 8 and 4 minus 8 over 8. So 12 over 8 is 4 over 2, no, 3 over 2. And then minus 4 over 8 is negative 1/2. All right. Example 2, which is actually 56 from page 849. So 5x squared equals 2x minus 1. Again, before we use the quadratic formula, we gotta set it equals 0, negative 2x plus 1. So 5x squared minus 2x plus 1 equals 0. A, B, C. X equals the opposite of b plus or minus square root of the discriminant all over 2a. Opposite of negative 2 is 2 plus or minus negative 2 squared, 4 times 5 times 1, all over 2 times 5. So this guy is 4 minus 80. No, sorry, 4 minus 20 is negative 16. We get 2 plus or minus. So since the discriminant is negative, we're going to get imaginary solutions. So 2 plus or minus I root 16 is 4 all over 10. We split it up. So it's 1/5 plus or minus 2/5 I. Alright. Now if you look at 48, page 849, it says use any method to solve. So if you're not sure you can factor it, then do the quadratic formula. It's just the easiest, the fastest. B, C, opposite of b plus or minus square root of b squared minus 4ac all over 2a. 9 plus or minus square root of negative 9 squared, 4 times 3 times negative 2, 2 times 3. So this guy, 81 plus 24 is 105. So x equals 9 plus or minus. Since 105 is positive and not a perfect square, you cannot square root that, so we're done. We get two irrational solutions. Two irrational solutions. 1 second. Okay, so now we're gonna go to number 66, page 849. 66, page 849. X squared over 8 minus x over 4 equals 1/2. So before we do anything here, we want to get rid of the fractions. We're gonna times everything by 8. So 8 times x squared over 8 is x squared. That's 2x, and that's 4. X squared minus 2x minus 4 equals 0. A, B, C. I subtracted the 4's just so you know. So x equals opposite of v plus or minus square root of the discriminant. That's 4 times 1 times negative 4. 2 times 1. Again, that's 4 plus 16 is 20. If you do square root of 20, it's square root of 4 times square root of 5, which is 2 root 5. So x equals 2 plus or minus 2 root 5 all over 2, which can be reduced because the 2's will cancel out if we square it up. So look, it would be 2 over 2 plus or minus 2 root 5 over 2, which is 1 plus or minus 1 root 5. Okay. Okay, number 80, page 850. 80, page 850. Let's look at that. It says, the person who wrote the instruction for setting up the badminton net shown below forgot to give the specific dimensions for securing the pole. How long is the support string? And I'm just copying what's in there. This is a 90 degrees. It says move up the pole a distance that's 4 inches less than the length of the string. So if the length of the string is x, then move up 4 inches less than the length of the string. That's x minus 4. And move out a distance of 1 inch less than half the length of the string. 1 inch less than half the length of the string. Okay, and then they want us to find the length of the string, x. So using the Pythagorean theorem, the hypotenuse is x, so x squared equals a squared plus b squared. That's what I'm using. So equals x minus 4 squared plus x over 2 minus 1 squared. So this is x minus 4, and this one x half minus 1, x over 2 minus 1. So that's x squared minus 4x twice, inner and outer, and then plus 16. So it's x squared minus 4x is minus 8x plus 16. For this guy, if you FOIL it, x over 2 times x over 2 is x squared over 4 minus x over 2 twice, and then plus 1. So it's x squared over 4 minus x plus 1. And that equals this guy, which is x squared. So let's see what we got. We can actually cancel out the x squared, so we get, because we're minusing the x squared. Oh no. Why is this frozen?